All right, today's objective, relations and functions. Let's go over some definitions first. Relation, a set of ordered pairs. Now, set is the key word here. Remember, we use set notation, we use a set brackets. Domain, the set of input values. Those would be your x values. So another word to say for your x coordinate is the domain, your x values. Range, that's the set of your output values, your y values. Function, a relation that assigns exactly one value in the range to each value in the domain. Okay? Function rule, an equation that describes a function. Function notation, when you use f of x to indicate the outputs. And as you just heard me say, you read that as f of x. X is your input, f of x is representing your output. And we'll practice that notation in just a minute. Vic number 1, you can use the vertical line test or a mapping diagram to determine whether a relation is a function. So remember a relation, a set of ordered pairs. Vic number 2, vertical line test. If any vertical line crosses through more than one point of the graph, the relation is not a function. That means that that graph is a relation. It is not a function. Remember, a relation has to be a function. There are special things for that. Okay? Vic number 3, mapping diagram. The domain, which is your x values, so the domains must all be different numbers. The range, which is your y values, can be the same number. So in other words, your x values must be different. They cannot repeat. Your y values can repeat. So that's a very nice little key point to make sure you check when you're going through to determine if a relation is a function or not. Let's go over some examples. Here I'm asking you to find the domain and range of each relation. So here's a relation. Remember, relation is a set of ordered pairs. So the domain, I told you, was the x values. So I'm looking at the x coordinate of every one. So remember, your notation is x, comma, y. So I know that this first number, 1, -4, 3, 0, and 2. That's exactly what I have in domain. Domain, we use a set because those are the set of numbers for our domain, for our x values. Range, well, that would be our y values. So we know it's the second number in our ordered pair format. So 3, 0, 1, 4. And notice I have 3 twice. And so I did not write it again. I only write it one time. Okay, so that's very important to know. All right, number 2. Again, I'm asking you for a domain and range. So domain is all of our x. So I have a 2, a -2, another 2, -2, and a 3. So those go twice. So I don't need to put those in there. So I have 2, -2, and +3. And that's exactly what I have listed for my domain. Range, I have a -3, a 3, another 3, and another -3, and a -2. So I have, those 3s are repeating again. So I know that I only have to list them once. That's kind of tricky to just make sure when you're writing them down that they're not in there twice. All right, example number 3. It says determine whether each relation is a function. So here is my relation, okay? Now what was a good trick as far as what Vic number 3 was saying? That all my x values cannot repeat, but my y values can. So I need to determine if any of these are repeating. 6, 5, 2, and 12. Are any of those repeating? Can I see them more than one time? No. So I know that this is a function. So here's a mapping diagram that tells me this. Sorry about that. All right, so a mapping diagram. I've listed out the ordered pairs. 6, 5, 2, and 12. Those are my x values. 3, -2, and 3, and -12. So I have 3, -2, and 12 I have here listed. So the 6 is being mapped to the 3. Notice I have an arrow there. 5 is being mapped to negative 2. 2 is being mapped to 3. And 12 is being mapped to negative 12. So notice I don't have any of my x values being mapped to the same x value being mapped to another, more than one y value. So I know that that is a function. Let's look at number 4. Is this a function? Well, first of all, if I'm giving ordered pairs, I'm going to check my x values. And I definitely see that the 3 is repeating. So therefore, this is not a function. And if I would do a mapping diagram of that, 3, 2, 1, 3, 7, 5, 6, negative 5. So I can see that the 3 is being mapped to the 7, the 2 is being mapped to the 5, 1 is being mapped to the 6, and then, the 3 is being mapped to the negative 5. So I know right here that I have this 3 being mapped to 2 y's. That is not a function. Alright, here we're going to do the vertical line test. Remember, vertical line test, it can only touch one point on that graph. So in red is the graph. So here's my coordinate plane, and here is the set of ordered pairs that we're going to see, is it a function or not. So how I apply the vertical line test is I have my vertical line, and which I'm using my expo marker, and any point in this graph, if I trace it, it is not hitting the graph more than once. So here, it only hit that graph once in any place I choose to apply the vertical line to. Okay, so yes, that is a function. Okay, so in other words, that's actually what we call a linear function because it's a line. Number 2, here's my graph. So if I actually apply the vertical line test here, notice that it's actually hitting the graph twice. Even here, it's hitting it twice. So anytime, so I know that this is not a function. Okay. Number 3, any point in here, definitely when I get to this one, notice that it's touching all through this line right here. So I definitely can tell when I apply the vertical line, I mean, the line is all over the vertical line test, so I know that it's not a function. Okay? Number 4, if I apply the vertical line anytime through here, the vertical line is only touching that graph one time. So any vertical line that I apply, so I know that this one is a function. Alright, so now we're going to evaluate function rules. So here I have f of n equals negative 3n minus 10, and I want to evaluate it for when n equals 6. So notice I told you that this is your input notation. This whole thing equals your output notation. So when I plug in 6 for my input, wherever I see n in my function, I'm plugging it in. I'm substituting it in. So if my input is 6, well, what's going to spit out is going to be my y. So negative 3 times 6 is negative 18. Subtract 10 from it, I get negative 28. So here's my input. What spit out? Negative 28 did. So this is my ordered pair. For when I put in 6, negative 28 is my y. So number 2, here I have y equals, and here is negative 2x squared plus 7. I want to evaluate it when I put in negative 4. So negative 4 is my x, my input value. So when I plug in negative 4, wherever I see an x at, negative 4 squared, positive 16. To multiply positive 16 times negative 2, I get negative 32 plus 7, which is negative 25. So here's my x, and there's my y. That's an ordered pair for that function. All right, here we have g of x equals negative 3. I'm sorry. G of x equals negative x plus 2. Remember, there's a positive coefficient sitting out there, but now I have a negative, so it's a -1 coefficient sitting in front of the x, plus 2. So when I plug in my value for x, I need to make sure I'm aware of that. So -3 is what I'm plugging in. So -3 times -1 is +3, and I'm going to add 2 to that. So when I plug in -3, which is my x, well, what spits out is +5. So my input-output, -3, 5 for that function. All right, last one. Finding the range of function rules. So let's find the range of each function given the following domain. So all my input values I'm using is -2, 0, and 5. Okay, so here's my first function. F of x equals x minus 6. So remember, wherever I see an x, I'm plugging in. The first input we're using is -2. So -2, when I plug that in, I get -2 minus 6, which is -8. So my first ordered pair, input, output, -2, -8. Now let's plug in for the domain for the next input is 0. 0, when I plug this in, I get 0 minus 6. Again, my input-output is 0, -6, which I put down here. Okay? My last ordered pair here, so my domain is 5. When I plug in 5, f of 5 equals 5 minus 6. That gives me a -1 output when I plug in 5. So 5, -1. This is the ordered pairs, and I know this is a function because none of my x's are repeating. Okay? So here, number 2, I have y equals -4x. So when I plug in, here's my inputs. So I'm going to use -2 first. So -4 times -2 is +8. So -2, 8 is my first ordered pair when I plug in my first input. So let's plug in 0. When I plug in 0, 0 times -4 is 0. So 0, 0. I know this function goes through the point of origin. When I plug in my last one, 5, I plug in 5. 5 times -4 is -20. So input is 5, output is -20. Here are my ordered pairs for that function. So let's do number 3. So I'm going to do the first one, -2. So I'm going to evaluate this one at -2. Okay, so I have -2 squared, so that's +4. So 4 plus 1 is 5. So my first ordered pair is -2 and +5 spits out. Okay? Now let's do g of 0. When I plug in g of 0, well, 0 squared is 0. So 0 plus 1 is 1. So when I plug in 0, +1 spits out. So there's my next ordered pair. So my next input is 5. And I'm going to use the same notation. So 5 squared is 25, plus 1 is 26. So when I plug in 5 as my input, 26 spits out. And notice I'm using brackets because this is set notation. So my range, which is also what it asked me to do, my range is all of my outputs. So 5, 1, and 26. Okay?